Hello everyone, this is Sumita Gupta. Welcome you all for my 20th lecture of Electronic Devices and Circuits, that is introduction of multistage amplifier. These are the outlines. So first of all, what is the multistage amplifier? What is the need of it? So understood, we have already learned clearly in the previous lectures, transistors behave like an amplifier. That can be a BJT amplifier, that can be a FET amplifier. But what is the need of multi-stage amplifier? Multi-stage means multiple stages. So listen carefully. If you remember, we use transistor as an amplifier means what we want in amplification, either voltage or power. But sometimes that voltage or power are not sufficient, whatever desire. So what we have to do, we have to connect multiple stages. That is the purpose of multi-stage amplifier. Again, listen carefully. Sometimes whatever the desired output, that is not sufficient by the one stage amplifier. So we have to connect multiple stages in series. Now to connect these amplifiers, we need some devices. Those devices are called coupling devices. Okay. So clear meaning multiple stage means like this is one stage amplifier, this is second stage amplifier. These two amplifiers connected in series with the help of coupling device. If we connect the multiple stage amplifiers, so what is the gain? Gain will be product of voltage gain of individual stages. Suppose gain of this stage 1, A1, this stage A2, then overall gain will be A1 multiplied by A2. Now the next question is, what is the purpose of coupling device? I have already explained you, different stages are connected in series or we can say cascading with the help of coupling device. But think about it. Can't they connect direct? What is the need of coupling device? That can be connected directly. Okay. So see clearly, we want amplification or amplification done by the AC signal. If you remember, the DC biasing was used to calculate the Q point and AC was used for the voltage and current gain. Okay, so we want to pass AC only, not the DC. So coupling device, the role of coupling capacitor or coupling device to transfer the AC from output of one stage to input of second stage. And so we want DC to block DC from output of one stage to next stage and to pass the AC. That is the purpose of coupling device. Now, which type of coupling component we are using? There are types of coupling: RC coupling, transformer coupling, and direct coupling. So first of all, RC coupling. If you remember, this is the BJT amplifier. Same method is same. In the place of BJT, you can use FET amplifier. The difference will be the symbol of transistor here. That will be of FET, and this capacitor will called not RC. It will be RD and RS. Only this difference. Otherwise, concept is same. So RC coupling. Now, see, this is the diagram of BJT amplifier voltage divider biasing. If you remember, we have learned different types of biasing and we understood the biasing, voltage divider biasing is the best due to the stability factor. Because stability factor was 1 in the case of VGT biasing, voltage divider biasing. So this is voltage divider biasing, one stage, okay. And this is the voltage divider biasing, another stage, okay. One stage VGT amplifier, another stage VGT amplifier, and these two stages are connected to the coupling capacitance. These two stages are connected through the coupling capacitance. And this is your collector, this is your base, this is your ammeter, this is the common ammeter configuration. So if you remember, base is your input terminal and capacitor is your output terminal. So as the output, what we are using? Resistance. The load is resistance and coupling component is capacitance. Due to the combination of this RC, it is called as RC coupling. Again, listen carefully. The load is resistance and these two stages are connected with the help of this capacitor. That's why it's called RC coupling. Clearly? Okay. Now the concept is same. Either you will use FET, MOSFET, but both stages will be connected through the capacitance. Then it is called RC coupling. This is the frequency response of RC coupling amplifier. At low frequency, this gain will be reduced. At mid frequency range, around 50 to 20 kilohertz, this will be flat, and at higher frequency, this gain will be reduced. So this is the frequency response of RC coupling amplifier. Now, advantages. You can see here flat responses between 50 to 20 kilohertz. So it's a wide range. Okay. So first advantage, wide frequency response, inexpensive coupling because we are using simpler capacitor. Due to capacitor, DC biasing of individual stages will remain unchanged even after cascade. Just pause the video and think about it. What it want to say? Due to capacitor, DC biasing of individual stages will remain unchanged. What does it mean? It is mean, if you remember the concept of small signal analysis, for DC biasing, the capacitors will be open circuit. If it is open circuit, these two stages are disconnected. Means the DC biasing is Q point of one stage will not affect the Q point of another stage, because these two stages are break during the DC biasing. During AC biasing, capacitor will be short circuit. This stage will be connected with this stage. But during DC biasing, the capacitor will be open circuit, means these two stages are different. So Q point of one stage will not affect the Q point of the another stage. And next is no core distortion. Disadvantage is no impedance matching, because we are not using such type of device like transformer and all. So there is no need of impedance matching. And another disadvantage is gain reduces at lower frequency due to coupling capacitor. If you see this frequency response, gain reduces lower frequency at higher frequency. A higher frequency, the reason is different, but at lower frequency, gain reduces due to the coupling capacitor. Here it is due to stray capacitor, that we will learn in the next lecture. This is the disadvantage. Overall voltage gain is less. So next, the application, it is used in the public address, amplifier system, tape recorder, TV, VCR, CD player, stereo amplifier, everywhere use RC coupling amplifier, because it's easy actually. Next type of coupling is transformer coupling. The same diagram. If you check this diagram and that diagram is same, only the difference of this load resistance. Okay, see here. And this, see here, what we are saying, RC coupling. So we are using RC here, load and the coupling component means connecting component. In both places, what will add? We will add one transformer. See here. Here transformer is used at load place, and that is connected to the base of the another. See, this is your one stage and this is your another stage. And both stages are connected through the help of transformer. The transformer at the load, that is connected to the base of the another stage. Then again it's a load that is connected to the base of the another stage. Okay, so the both diagram are same, only the difference of transformer. Okay, so when we will plot the frequency response of this coupling, what will happen? Up to here it will behave like a RC coupling, but during high frequency there will be a peak. It will suddenly increase and decrease. That is we called resonant rise. Okay. Now advantages, since we are using a transformer, so impedance matching is possible. There is no difference of impedance. Higher voltage gain than RC coupled. That is the main. The voltage gain which we are getting from RC coupled amplifier, the amount of that gain was less in the case of RC coupling. Now we are getting the higher voltage gain. And the next point, the same DC biasing of individual stages will remain unchanged even after cascading. Okay. Now, disadvantage is coping transformer. Means whatever transformer we are using that is bulky, definitely it will be expensive than the capacitor. Frequency response, we are not getting flat. There is a possibility of co-saturation and low efficiency, because due to transformer there can be some losses. Okay. Now, application for radio frequency signals amplification, power amplifiers, impedance matching. Now, third type of coupling is direct coupling. Is we are not using anything. We are not using any resistance, capacitance, not any transformers. We are directly connecting. We see here it's not shown the voltage divider biasing, but you can connect it like this, voltage divider biasing. Okay. Now this output of first stage is directly connected to the input of the next stage. That's why it's called direct coupling. In direct coupling, we'll get the frequency response like this. First flat, after that 3 dB down, then it will suddenly reduces. Okay, so this is the frequency response of direct couple amplifier. Now advantages, if you will check, so we are getting a large bandwidth. Bandwidth means there's range of frequency where the gain is constant. We are getting a large bandwidth. Definitely cost is reduced because we are not using any components for coupling. So there is no complexity because components are very less. And the simple thing is, if you remember the response of the previous one, there is no gain loss at low frequency. Gain is reduces only at the higher frequency, not at the lower frequency. Disadvantage is, the main disadvantage, DC biasing of individual stages will change after cascading, because since there is no capacitance, so when we will do DC biasing, Q point of first stage will affect the Q point of second stage, because these two stages are not different. In first case, they do this capacitor, those two stages are separated, but now two stages are not separate. So whatever the Q point here means, whatever Q point means, whatever the current IC and BC here, that will be input to it. So due to that Q point of first stage, the Q point of second stage definitely change. So disadvantage is DC biasing of individual stages will change after cascading, and definitely at high frequency we are not getting the desired output. And poor temperature stability. Application, we generally use it in op-amp, operation amplifier, and voltage regulator. Thank you so much. If you like it, share. If you are having any doubt, please comment in the comment box. Keep learning. Thank you so much. God bless.